All right. Hopefully that I am well and clear to everyone. My audio is clear. All right. So good morning. For today's session, we will start around 9:30. Okay, so tama, 9:30 lang. Today we will start by showing all the things that are used in data science as an alternative for predictive analytics. Okay. So last time on our topics, we discussed about exploratory data analysis. So we explore using the Northwind dataset. We try to merge the different tables inside the Northwind dataset because that's how usually is happening in our work as a data science. The company has its own data storage, data architecture, and we would need to combine the tables in order for us to do some exploratory data analysis to those databases. All right. So what we did there during our study is the descriptive analytics. Uh, the branch of descriptive analytics that handles exploratory data analysis, where we use visualizations, we implemented matplotlib, right? So that is more of like descriptive analytics. So we describe the data, we understand the data by means of exploring the data. And then somewhere there, we need to provide a recommendation from our data. So underlying our activities last time, we implemented some sort of diagnostic analytics where you provide recommendations on the certain analysis that you have done on your certain tasks, all right? So usually diagnostic analytics is used to answer questions like, why did it happen and what caused the problem? So when will be the time for us to implement diagnostic analytics? The time is when a problem happens and we wanted to know why did that happen? For example, inside a supply chain company, usually in a supply chain company, what you are managing is the goods or the supplies should be processed and go or route to the customer, right? So meaning we need to understand, let's say if there is a delay, we want to know what is the cause of that delay. So we will implement analytics to know the cause of the delay. Let's say we order 300 pieces of chicken breasts to multiple suppliers. If we will order 300 chicken breasts to, let's say, 10 suppliers, who is the supplier that delivered it on a delayed time, something like that? And then what caused the problem? So we will try to know the root cause from our data from analytics. So that is diagnostic analytics. Then we will now proceed to predictive analytics. So predictive analytics, we will use statistics or statistics learning and also machine learning to harness the predictive capability of these algorithms and provide some future data or future solutions. So the keyword of predictive analytics is we classify or we predict what's going to happen, or most likely what will happen in the future. So using our data, we some kind of like predict what will happen to the future. Let's say the use case for predictive analytics is we want to project our sales for next month. Based from our historical data, we want to predict our sales for next month. What can be our sales for this month? So given that our data from our descriptive analytics, we found out that there is a seasonal pattern on our sales. So given that there is a seasonal pattern in our sales, we can have a prediction for our sales next month. And also, using predictive analytics, we can do hypothesis testings and what else? Hypothesis testing and I forgot the other term, but we will go there later. So going back, using predictive analytics, we can predict the sales of next month, and also we can do some hypothesis testing. And now, if we're talking about prescriptive analytics, most of the time, this is a combination of different experiments coming from descriptive, diagnostic, and predictive analytics. So if you combine these three, descriptive, diagnostic, and predictive analytics, for a certain period of time, you can do prescriptive analytics. Usually, if you're going to do prescriptive analytics, your data should be more than 3 years. So 3 years and more. What data am I talking about? Past data. And past results coming from descriptive, diagnostic, and predictive analytics. So the problem with prescriptive analytics is that this is the final output. You will now collate all of the reports. If you don't have the reports for descriptive analytics, diagnostic analytics, and predictive analytics, you cannot do prescriptive analytics. Yeah, right. So that's the prerequisite of prescriptive analytics. So this one happens usually after series of projects from this tree. So what usually happens in prescriptive analytics? You are providing 3 paths. Okay? In Tagalog, nagpo-provide ka ng 3 pathway or 3 tatahakin na landas ng company. You want this path? Do you want this path? The company will say, no, I do not like it. Can you suggest another path? Okay, so I suggest that we take this alternative path. Do you like this alternative path? The company will respond, no, maybe I want another option. So you will suggest, this is the 3rd alternative path. Would you consider this one? And then your company would say, I think this is much better. So prescriptive analytics is providing a business path to your company that you are working with right now. So basically, this comes from a lot of descriptive, diagnostic, and predictive analytics. But today, we will be focusing on predictive analytics using some basic statistics or machine learning algorithm. So in summary, descriptive analytics focuses on understanding past events. Diagnostic analytics focuses on understanding why something happened. Predictive analytics focuses on predicting the future events. And prescriptive analytics focuses on recommending the best course of action to achieve specific outcome. So each type of analytics plays a unique role in helping organizations make data-driven decisions. Okay, so pag na-master natin to, yung apat na to, descriptive, diagnostic, predictive analytics, and prescriptive analytics, we can say that we provide help to the organizations that we handle data-driven decisions. All right? So that's the, let's say, if you're going to create your resume, you are going to say to your resume that from my previous experiences using descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics, let's say you have done these four in the past. You can summarize your experience by saying you have helped your previous organization to make data-driven decisions. And to add a cherry on top, you can add there the results and the evaluations from your different kinds of analytic projects. Let's say you have deployed your descriptive analytics to a certain company and they provided a result of evaluation, and the result of the evaluation says that you got 5 out of 5. So you can put that as one of the reasons to say that you have done your projects correctly and efficiently. All right. Naintindihan ba yun? Do you understand? Press 1. If you have, do you have questions regarding that? I hope you're taking down notes. If you want to recall what was the topic that I am saying earlier. All right. So next is we will be focusing more on predictive analytics. So when we're talking about predictive analytics, we are going inside the topic of machine learning. And inside the topic of machine learning, and this is one of the most heard buzzword in the industry, we are talking about supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. So there are 4 kinds of machine learning. Remember that if someone will ask you, what are the different kinds of machine learning? You can easily say that there are 4 kinds of machine learning. Number 1 is supervised learning. Number 2, unsupervised learning. Number 3, reinforcement learning. And number 4, semi-supervised learning. So what are the things that are happening inside supervised learning? Supervised learning is where you provide a data to a machine and your data has a tag of the facts or some kind of like, if you provide, let's say, let me have you Jamboard. Let me draw this to the Jamboard so that we can easily understand. Okay, so for the supervised learning, so supervised learning, or let's say SO, what is happening there is we provide a data. So imagine your data is this circle. So this is your data. All right. So your data has two parts. So your data has two parts. It has facts and features. So these facts and features come along with the data that is intended for supervised learning. So in simple saying, you provide facts in a supervised learning, machine learning technique. So you provide facts. So this is an important feature for supervised learning. So the person and the machine, let's say there are two entities. So the machine is something like this. Let me change the color. So this is the machine. And this is the person. Okay. So the person tries to be a supervisor to the robot or the machine. So the supervisor provides facts for the machine to follow. Okay, so the machine only follows in this kind of machine learning. And who's going to provide the facts? Okay, let me ask you a question. Who provides the facts? Who provides the facts? Machine or the person? The person, the people, basically us. The data scientist prepares the facts coming from the data. So what is the data that we are talking about here? Let's say you have a data and we call this one house prices. So our data is called house prices. So we provide features to our data. And then we also provide facts. So this is part of the fact. And this is the part of the features. So we have a fact and the features. So let's say, what are the features? Bedroom. Okay. Bedroom. What else can we have for the features of the bedroom or the house? If we're going to provide the features for the house, what are the features of the house? And for the facts, we provide the price. So what can we provide as features of the house prices data? Hello? Parking, all right, sige. Parking, what else? Rooms, bedrooms, rooms, square foot. Sige, square foot. What else? Okay, sige, we can do that. Furnishing. Okay. So let's say we have 1, 2, 3, 4, 5 features. So now we need to get the values. So for the bedroom, we can say 2 bedrooms and then 2 parking lots. Wow, usually we have 1 parking lot, no? Square foot, siguro 100 square or 25 square foot. And then what else? Furnishing, fully, right? So probably the price is 1.5 M, right? So this is what I'm talking about. So these are the features of your data: bedroom, parking, square foot, furnishing, and you provide the values for the features. And then at the end, at the last column, we provide the price. So the facts usually is our can we say that this is our independent variable? So we can provide y, and these are the x features: x sub 1, x sub 2, x sub 3, x sub 4. And this is the y prime. All right? So the independent variables are the features such as bedroom, parking, square foot, furnishing, and then dependent our dependent variable is the price. So because of the given x's, we will provide the fact, which is y. So by means of the formula of linear regression, we can do this one. So the formula is with a series of x's, we will provide the y prime or our prediction. Let me just write it correctly. So y prime so with a series of this independent variables, we provide our y prime, our prediction. So that is a explanation for supervised learning. Okay, so let's go back. Unsupervised learning is the same with this one, but we're going to remove the facts. So you're just going to remove this one without telling the machine the facts of that house prices. The machine would try to know on its own the outcome of the data. So again, in a supervised learning, there is a robot or the machine, and there is people and person providing the facts. Providing the facts to the robot. In the unsupervised learning, the robot has no supervisor, and no facts. The only thing that the robot is getting is features. So that's the only thing that the robot knows, features. So that is the difference between supervised learning and unsupervised learning. So for the supervised learning, usually the robot has a supervisor, which is us, the people, supporting the facts. In unsupervised learning, the robot doesn't have a supervisor, but should be supplied by features. So there's no people providing the facts, but only getting the features. So the robot only gets the features for this kind of prediction. All right. So we also have reinforcement learning. So this robot also doesn't have a supervisor. And what happens is the robot is actually experiencing the event. So the robot is like an agent. So the robot is like an agent in a what we call reinforcement learning. So reinforcement learning. So the robot is experiencing the environment, and the robot is called an agent. Then the environment, usually we just provide the robot with certain kind of outcome and penalties. So the robot is provided with a good or a bad, what do you call this one? Threshold, something like that. In simple saying, let's say the robot is experiencing the environment, given that the robot can, let's say, manipulate the sensor it has, it will be tested at the end if it is good or bad. So reinforcement is coming from this activation, good or bad. And then, of course, the robot is towards becoming good. So the robot is penalized for becoming bad. For becoming good, it is rewarded. All right, so that's what's happening in reinforcement learning. When the robot or the agent is experiencing the environment, the robot is responding to the good and correcting itself from the penalized coming from the bad uh, outcome. All right. So that's how reinforcement learning, that is actually advanced. So most of the people who are doing the reinforcement learning is specialized in AI. Reinforcement. Let me correct the spelling. So data scientists that specializes with reinforcement learning are towards AI. And then next, we have semi-supervised. So for semi-supervised, the robot is also provided facts. What's the color that I'm using? The robot is provided by facts. While experiencing good and bad. So that's just the difference between supervised, semi-supervised learning versus reinforcement learning versus uh, supervised learning and unsupervised learning. I hope you got that explanation. Do you have any questions with that for different kinds of machine learning? Hello, do you have any questions regarding that? Okay, good. So now let's proceed to our example, which is linear regression, or we could say supervised learning. So our outcome is to provide prediction. Okay. So using supervised learning technique and our model linear regression, we can create or solve prediction problems. So let's go and click. Let's go and click with our notebook. Okay, so this one in our Google Colab, we will use different kinds of libraries. So we will use the pandas libraries, the numpy library for the plotting, and then import seaborn for some kind of plotting. So most of the time, these two, numpy and seaborn, they are used for plotting. Then we will use the sklearn. So remember, this sklearn is, ano yun sabi? Meaning, sir, yung semi-supervised may threshold din. Yeah. And that is also advanced machine learning techniques. So in our case, we will start with the basics, which is supervised and unsupervised learning. All right. So here, remember that we will be implementing sklearn. So most of the time, when I see job postings in LinkedIn and also in JobStreet, people are looking for data scientists that has experience with sklearn. So sklearn is a library in Python where we use to implement the already created functions such as trains test split for our model selection. And for our model, we will be implementing linear regression. And then for our evaluation metrics, we will be implementing accuracy score, mean square error, and R square score. So my question is, who has experience with linear regression from your past? Let's say, do you have any experience with linear regression from the past? Does any one of you have a experience already with linear regression? Is this the first time? Press 1 if this is the first time. Okay, good. So if this is the first time, let's start with Excel first. Okay, let me explain it. The intuition behind linear regression. How can it predict? Okay, so let's have a simple example of our data. So our data is, we want to know, or if we can predict the grades of our students in their math class. Again, we would want to predict the grades of our students in our math class. Let's say I am the math teacher. I want to predict what will be the final grade of my student to this math class that I'm teaching. So let's have an experiment. So we have here students, and then students, let's say we have student 1, student 2, student 3, 4, 5, 6, 7, 8. So we have 8 students, and this is their math entrance exam. So this is their math entrance exam result. And this is the math grade of the student. So take note that this is a past data from my survey. So given that we are going to use the previous survey, so from that survey, probably student 1 has a grade of 78, and then another student has a grade of 88, another student has a grade of 79, grade of 90, 94, 85. All right. And then on their previous math grades also, here is their data. Okay. So let's say this is my previous data. According from the data that I have, I want to know okay. So this is our let's say this is our hypothesis question, or should I say our experiment question. We want to know if the past data can predict the score of a new student coming in to my class with only the math entrance exam grade. So for us to know that, we want to implement some kind of model to predict that kind of phenomenon. So let me just graph the first column and the second column into a scatter chart, something like this. Okay. So the scatter chart focuses on uh, displayed this result. All right. Can we adjust? So the minimum is 80. And then what axis is this? Minimum. And this one, we want to start also with 80. Okay. So this looks better. It's much more zoomed in. So it is actually zoomed in because we started, instead of 0, we started with 80, because our scale starts with 80, somewhere around 78 up to 99. Okay, so if I'm going to include 0, it will look like there are some spots only in the upper right side. So by changing the scale from 80 to 100, we can observe closely what is happening to our points. Now, linear regression is putting a hyperplane trend mark to our data. So where is that option? Kita ko na yun kanina. Ba't nawala? Teka lang. Okay, so dito na pala nila nilagay. Ito na pala. Wala na dyan. So ayan, lagyan natin ng trend line. Okay, so we're having a trend line. And then this trend line, we can place the equation on the chart and display the R. Okay. So what I did there is, what actually doesn't matter. What I did there is I just added the trend line here. When I click on the trend line on my Excel, using this trend line options, I will select linear, automatic, check the display equation chart, and display the R squared value on the chart. So the R squared value on the chart is 0.87, or should I say 87%. So what is the meaning of that? If I'm going to use this past data, if I'm going to use this past data, to predict the grades of my incoming students, I could say that my estimation or prediction has a confidence of 87% or 0.8726 or 87.26%. So with a marginal error of 13 or 12%. So in simple saying, if I'm going to predict your grade coming from your math entrance exam, I have 87% confidence that my prediction is right, and I have 12% error most of the time on my predictions. So having said that, if the 100% is the totality of my predictions grade, I am always getting 87% correct on my predictions. Therefore, let's say your grade is, my prediction now is, let's say a new student came in. The new student has a grade of 87. Okay. What can be his math grade using my past data? How can I predict that? So using this formula, so 1.4441 multiplied by 87 minus 8.1982. So we need to use a parenthesis because this is, we need to use a parenthesis because we need to first multiply it before we do the minus 8.1982. Okay, so let's know the answer. So our prediction is 117. Sobra na. Let me just calibrate my equation. Let me just calibrate my equation. Wait for a while. Okay, so my prediction, I was just having a short error or small error with that. So instead of 1444 earlier, I changes to 1.1. Yeah, right. Okay, so this is the prediction. Okay. So if we get another new student, let's say the grade of the student in the entrance exam is 67. Okay. So we can transpose that here. Possibly the grade of that student in the on the math course will be just around 68.45. So not good, right? So meaning we can say that if your grade is 75, can you be good at my math subject? Okay. So I will accept students with a grade of 75. How about with a grade of 70? I will not accept the students from having a math entrance exam of 70 because they will eventually just fail on my math course. All right? 74. Can I accept that kind of student? Maybe, because there is still room for errors. I think the confidence is around 77. If the student has a grade of 77 on his math entrance exam, the potential for the student to pass on my subject has 85% chance to be 79.8975. So I would accept that student. But if I'm very strict, I will accept all the students with a grade of 80 on the entrance exam because I still have an error of 12%. For that kind of error, let's say 12%, for that allowance error, I would decide that 80 would be the determining factor for me to accept the student because eventually he will perform good and pass the course if the student has a grade of 80 on his math entrance exam. Do you have any questions to this one? So, tanong ni Stephanie, saan nanggaling yung 1.441x minus, actually, ano yan, sinosolve yan using the linear regression formulas dito sa trend line na to. However, ginawa na sa atin ni Excel yun. Okay? Ginawa na ni Excel yung computation na yun for us. So, ang ginamit ko na lang is yung provided solution ni Excel para sa atin. So, this is the provided solution of Excel for our linear regression. So, remember, di ba, I check display equation on the chart, right? So remember, I check the display equation on the chart, meaning based on this data, Excel already performed the equation for us, and we just need to plug in the value of X from the formula Y equals 1.1441x minus 8.1982. All right? So we plug in the value of X. So in machine learning, this is our X, our features, and this is our Y, our facts. Okay? Nakuha ba? This is our X. And this is our Y. Remember, in-explain ko kanina to, house prices. Diba meron siyang features, which is mga X, X sub 1, X sub 2, X sub 3, X sub 4. And then we have facts, which is the Y, or the Y prime. In this example, we only have one feature because our problem is not so complicated. Usually, saan ginagamit to? May question ako sa inyo, saan to ginagamit? Yung ganitong business problem or na-encounter nyo na ba to? Press 1 kung you encountered this kind of situation. Sigurado kayo, hindi niya pa na-encounter to? Na-encounter natin to. Almost lahat tayo na-encounter natin to. Alam niyo kung saan? Di ba kunyari, nag-ano ka, nag-a-apply ka ng college, di ba may entrance exam? So usually, nilalagay mo doon kung anong course ang kukunin mo, di ba? Di ba, lalagay mo doon, kunyari ang course na kukunin mo, engineering. Yan, gusto mo mag-engineering. Tapos may entrance exam. Bakit may mga hindi pumapasa na gusto engineering? Kasi according to this study, kung mababa ka sa entrance exam, math entrance exam mo, tsaka science, hindi ka pwede sa engineering kasi babagsak ka lang. Sayang ang oras mo. Kaya marami ang hindi pumapasa at nakukuha sa mga state universities. And ano yung kanilang theory? This is their theory using linear regression from their past data. Yung mga hindi nakapasa sa entrance exam, most likely hindi rin makakapasa dun sa mga courses nila sa college. Kaya nare-reject ka. Hindi ka po pwedeng mag-enroll sa mga state universities such as UP, Ateneo, UP, PUP, something like that. Yes, that's the reason why. Bakit may entrance exam? At bakit mayroong quota? Yes. Ang example ko dito, mga engineering. Kasi di ba math, maraming matang engineering. Yan. Okay, nakaka-relate na kayo ngayon. Press 1 sa mga nakarelate. I just need to know the responses of the people. Very good, very good. Okay? So in this sense, magagamit din natin siya sa pag-predict. Kung napipredict natin yung score, yung possible score using linear regression, di ba? Dapat maintindihan din natin yung performance ng model natin. In this example, based on our data, our linear regression is performing good because it's 87%. Okay? Lakayan nga natin to. And it's 87%. Our R squared is 87%. But not most of the time that is good. I don't know kung ganyan din yung sa mga poll ng election, but most likely meron yung relationship. So pwedeng mag-predict. Basta meron lang tayong data. Okay? So magkaroon tayo ng, ito yung importante sa ano natin, sa model building natin, yung R squared, because the R squared is our accuracy. Okay, that is the level of accuracy in our model. But in some cases, yung accuracy natin hindi laging 87%. May mga panahon na mababa siya. Okay, so let's try to have a short game. So we need to guess the correlation. But before that, bibigyan ko muna kayo ng context. Okay? So this is the context. And then, Ba't ganun? Ba't ang itim? Okay, focusin natin to, no? Kapag ganito siya, makikita nyo ba, press 1 kung nakikita ninyo yung example ko. If you can see my example. All right. So let's observe this context. If you can see, the first one, all of the points are scattered. So the R score is 0.0. Okay? The points on the second one is semi-scattered, so it's 0.5. So in the next example, 0.75, the dots are kind of like merging already. And next, on our fourth example, 0.90, the points are getting close with each other. And 0.95, they are some kind of really, really close. And 1.0, they are aligned. Okay, so this is the scaling. So this is the scaling context. Now, do you understand the scaling context of the R's or of the R? Nakuha niyo ba yung pattern? Do you kind of recognize the pattern? If the R is increasing and is getting close to 1, the points are also merging and aligning together. All right? So let's test that knowledge. Let's go to the guess correlation. So we will just resume the game. So for this one, I want to know, what is your guess for this kind of dots? $1.5. Meron pa ba? 1.5? Ano pa? 0.0. 0 daw. 0.5 lang po. Sige, let's try 0.5. Okay, 0.5. If we're right, if we are right, our hearts will increase. If we are wrong, our hearts will be deducted in this round. All right. Let's play. Enter. Okay, so we did not lose because the true R is 0.57 and our guess is 0.50 and the difference is only 0.07. Therefore, we pass this one. Okay, konti na lang, yes. Pero at least we pass. So siguro, kung in-answer ko dito 0, magkapasang-awa. Okay, so next natin. How about this one? What is your guess? Remember, this is our context. If it is closely getting together, it's close to 1. If it is scattering, it's close to 0. However, we need to estimate properly. So let's say 2, according to Samuel. Is this our final answer? Okay, is this our final answer? We're going to die if we will lose this round. Look at our hearts. We don't have our hearts anymore. But if we will try to if we will try to guess this correctly, we will receive a new heart plus an additional gold coin. So what's our answer? Final? Okay, let's try to click enter. Very good. So 0.26 is the true answer, and we guessed 0.20. So we just have a difference of 0.06. Another one? How about this one? .75. So the right answer is actually 88. We guessed 75. The difference is above the threshold, which is 0.13. So we lose another heart and it's game over. We can play again, by the way. So how about this one? Let's try another. Let's try another one. How about this one? 0.9, 0.9, 0.85. Do we have another one, another guess? So let's meet in the middle. Around 87. Let's try at 87. The true R is 94. And the difference is just 0.7. Our guess R is 87. So we're close, around 0.7. Very good. We did not lose any heart. Okay? Pero mas malapit si Celso doon. Yeah. Do you want to try another one? Or you get it already? Okay, maybe we got it already. So let me just explain further. Okay, so what we are doing there is guessing the performance or guessing the R squared of our regression or our linear regression. So let me just draw different kinds of regressions. Okay. If our trend line is going this side, wala akong dots. Siguro ito dot. Okay. Siguro yan ano. So we have different kinds of ano kasi relationship. So this is positive correlation. and this is negative correlation. So depending on the trend line, you will provide some kind of relationship. Wala kasing tuldok eh. And ayun na lang. Maliit na lang. So this has no So what is the thing that we're going to avoid? We're going to avoid no relationship. So usually, if we see this, there's no correlation. If our trend line is horizontal, there is no correlation. And if that's the case, we cannot predict using our data set. We want to have at least this kind of level to predict. So the prediction is an absolute value. Therefore, even if it is positive or negative, we can still predict. So the prediction is always absolute. Any questions for this one? After this lecture, before we go to our linear regression program, we will have a short break. But before that, do you have any questions? Okay. So there are no doubts, there's no questions. Let us have a 15 minutes break. Okay, so let's continue. Can you hear me now? Okay, so let's continue for our code. Let's resume coding. So in this one, we will implement linear regression from our data sets. So our data set is coming from this one. So just click here and you will get all the data set from our repository. So kindly get CTs because that's what we're going to use. We're going to get CTs and fish market. What else? What else are we going to get? Yeah, so for that, we're going to get the fish market and okay, so we also we're going to use real estate data set. All right. So let us upload all the data set that we need. Where did I put it? Something like maybe I removed it here, so I'm going to download. I see files. This. Let us just download. Let me just download it. Yes. Okay. So I downloaded all the data set that we need. So we start again with our imports, our libraries. So this is pandas for our data frame, numpy for our plotting, then sklearn for our train test split, linear regression, our evaluation metrics such as the accuracy score, mean square error, that are two score, and then also matplotlib for our graph. So let me load all of that. Okay, load all the libraries. So let's look at the cities. Let's load the cities.csv file. Okay, so we can check if that was successfully loaded. Okay, so that's our data. So our data for the cities has city, country, latitude, longitude, temperature. So we will try to imitate what we done there from our experiment. So we need to get our independent variables, our x until x sub n, right? So in our example, which is the cities.csv, we need to know the numerical values to be used in our linear regression. So we can use latitude, longitude, temperature. All right. So we can see that we all have these columns. We have city, country, latitude, longitude, temperature. We need to know the most important independent variables to be used in our regression. So we will be using latitude, longitude, and temperature. Okay, so again, our supervised learning model, we can use latitude, longitude, and temperature. So we can decide that our facts will be the temperature. So that can be considered our facts. So our fact is our dependent variable, which is the y prime. And the values of the temperature are numerical values and also numerical values for our features. Our features, latitude and longitude, okay, so for our features, we have latitude and longitude, then our temperature. All right. So we will be selecting for our linear regression, latitude as our x, our independent variable, and temperature, our dependent variable. All right. So let's play. Then we need to get the correlation score. Okay, so what is the correlation coefficient? So for the latitude, we get negative 82.41. So it's A. What's the relationship? Let me ask you a question. What is the relationship according to our correlation matrix? The relationship is negative. So our relationship is negative because it's going down. How do we say it's going down? If the latitude is going up or the value is increasing, the temperature is decreasing. That's why it's a negative correlation. So we plot our correlation CMAP. Okay. So this is our CMAP. Okay, so this is our visualization. So which means that it's negative because it's white. It's positive if it is blue. So we disregard the ones because that is pertaining to itself. All right. So this is the reason why it's negative, because the plots of latitude and temperature has the direction going down. Whenever the temperature is rising, the latitude is actually lowing or getting low. the latitude is getting low if the temperature is also if the latitude is getting high, the temperature is getting low. If the temperature is getting high, the latitude is also getting low. That's why it's there. It's just around 34 for the latitude for the highest temperature. And then if the latitude is 65, the temperature is just around less than 5. So therefore, the relationship is negative because there is opposing poles, right? Now we do our prediction model. So our prediction model, we need to put city's latitude to our X, and then we need to put temperature to our Y. Next, our X and Y will be placed in our train and test split with a test size of 0.2 and a random state of 42. So what does that mean? It only means that if our value is test 0.2, meaning it's just to 20%. So if your data is this around 100%, so you get the 20%. And this one around here is just the 80%. Okay? So that's what it means when we say test size 0.2. And the random state 42 is just an arbitrary number that says we need to randomize the selection with around 42, any arbitrary number from 0 to 100. All right? So what are we splitting? The values of X and Y that we placed here. Now, what will happen there is we have X test, and then X train, we have Y train, and then we have Y train, and then we have Y test. So what will happen there is when we split this one, the 80% will be going to the X train, and then the Y train. The 20% will be for the X test, and then the X train. Did you get that? Nakuha ba yun? Please respond. Okay, so that's what's going to happen here. Then we are going to use our model. This is already created for us, so we will not going to create the program from scratch. So we imported linear regression on the top, this one. We just inputted the sklearn model, which is linear regression. So we're just going to apply that in our prediction model. So our model is linear regression. Now we train. We train our model, regressor.fit, X train, and Y train. So where did it came from? We came from X train and Y train. So what I mean is in our training, in our model. So our model is the robot. So this robot is being trained. So the machine is being trained with what? Saan siya tinitrain? It's trained by X train and Y train. From our data, here from our data, X train and Y train, the 80%, so the 80% of the data so the 80% of the data is for training. So X train and Y train. So the robot is being trained by the 80%. Okay, so that's what happens here. And now we will test the robot. So we use the regressor. Now we use the regressor that predict instead of fit. Remember that if you're going to use regressor that fit, you are training the machine. And then when you use regressor that predict, you are testing the machine. So we're going to test the machine. So in the machine testing, we get the 20%, right? So we get the 20% of our data from X test and Y test, right? Y train and Y test pala, sorry. Y train and Y test. Ano ba yan? So, X test, Y test, X test. So what happens here is the robot now trained robot will accept the trained robot will accept X test and then the robot will predict Okay, so Y pred. It will predict to Y pred. Right? So this is what's happening. Now, we want to know the mean square error or our error from our prediction using the MSE. And then also we wanted to get the R squared score. So we just use the Y test and the Y pred. So this is more of the evaluation. Now we get, let's run the model. Now we get 59% for our R squared. So meaning the confidence of our prediction is around 59%. And then it's 3.34 for our mean square error. So meaning this graph is just 59.81 for our R squared. Okay. So if we have a new data, we will predict something from 59, or we can round it off to 60%. So we have 60% accuracy. However, our mean square error is just 3.3. Therefore, it's still good. Imagine if there is errors, our errors will be around 3.3. So maybe you are thinking, why is it 59.81 tapos 3.3 lang pala yung error? Dapat, di ba, 97? Kaya lang siya naging ganyan kasi ginamit lang natin siya sa maliit na portion ng data natin, which is the 20% of our total data. But if we're going to use that in the totality of our data, that will be around 90+%. So in simple saying, if we're going to use 20% Y test and Y predict, we will rely most of the time with the mean square error, because the mean square error estimates the Y test and Y prediction only. So let's say I will predict a temperature. I will input a latitude and therefore it will predict a temperature somewhere. Let's say our latitude is around 55. What will be the prediction? So the prediction is around 6.3. Let's see on our graph. Okay, so I think it's around this area. Can you see my mouse pointer? Plus, can you see my mouse pointer? Okay, so this is around this area. So our prediction is around this area, which if we will compare that from our historical data, it's accurate, right? Therefore, we can say that this model is good model because it has a mean square error of 3.3. What will be the bad model if that's the case? A bad model will be mean square error more than 20%. So if your mean square error is around 20% or 20 point something, uh, you will say that your model is not very good. Any questions? So don't mind lang tong dalawa. This is not important. Any questions for that? May doubts ba kayo doon? Questions? May question kayo? So what's your question? If there are questions, please write the question. Clarifications. Okay, let's have another example. By the way, this one is just me plotting the Y-pred and the Y-test. So this is just plotting. Okay, plinat niya lang siya. No? So this is based on the X test and Y pred. So these values are, how many are this? Basta galing lang yan sa 20%. So this is coming from the 20% and this is the trend line. So the R squared of this trend line is around 59. So yeah, if we're going to get the actual R squared, we need to combine all of our data set. So for getting the final R squared, we need to get the whole data set, no? To get the accurate R squared. So in this case, we were going to use mean square error. So mean square error yung determining factor natin kung bakit okay yung model natin. What is the meaning of mean square error? Ang ibig sabihin ng mean square error kasi, let's say, ito yung Cartesian plane natin. And sabi nga dito, di ba? Ito yung itsura ng Cartesian plane natin using the Y-pred and the Y-pred and the Y-test. So, meron siyang regression line na pa ganun. Apologize lang kasi my line is not perfect. So may mga data dito, right? May mga data. The data is actually somewhat spreading a little. Okay, since the data is not going to explain the totality of data, we eliminate the R squared at this point. So we're not going to rely on R squared. We're going to rely now on the distances of the points to the trend line. So the distances of the point to the trend line is computed as the sum of errors. Okay? So yung mga yan, these distances are computed as sum of errors. The longer the point coming from the trend line, that is the value of the error. Okay? So what are you going to do with the sum of errors? You will get the mean. You will get the mean. You will get the mean. So basically, that will be a signed value. Getting the mean means getting the average error. Average summary of errors. So the average summary of errors, to get the absolute value, we square. We square using square, we get the absolute value. So the result is the mean squared error. So the mean squared error is now our evaluation metric to determine how good is our model. So the mean squared error has a range or a scale of 0 to 100. So the good one is near to 0, and the bad one is close to 100. Therefore, if our mean squared error is just 3.3 next to 0 or very close to 0, therefore, if you transpose it, our accuracy will be around 97%. And our mean square error is 3.3. Did you get that? Kabaliktaran lang ng error yung accuracy, di ba? The inverse of error is accuracy. So if you get 3.3 as your mean square error, if you get 3.3 as your mean square error, of course, your accuracy is the inverse of 3.3. So you get 97.7, right? So our accuracy is good. It's better. It's 97.7. So the total R squared is 9. So our total R squared is 97.7. Nakuha ba yun? Did you get that? Para malinaw. The R squared of y test and y prime. So what is the actual R squared? The actual R squared talaga is the total data set. So the total data set is the total data set is ano yung ginamit natin kanina dito? Ito. Hmm? Ano ba yan? Pipindot. Hmm? So this one to get the R squared, we R squared is correlation matrix CTs dot Taylor 01 multiplied by 2. Therefore, the R2 is 67. 67 pala yun. So the R squared, the real R squared is 67 ganun. So R squared. Hindi rin nagkakalayo pala. Right? So for next example, the fish market data set. So we use the fish.csv, and then our columns are species, weight, length, length 2, length 3, height, and width. So we will try to transform the species into a numerical format. Okay, so before that, we need to run this one. Okay, so we have 7 numbers. And then we have roach, bream, whitefish, parky, perch, pike, smelt. And then we need to do a label encoder. Okay. Fish. Species. So instead of data, we need fish. Transform. Ayan, so we will have another value which is species encoded. So instead of data, we use fish. Okay. Fish. Same lang yun ah. Fish. So we will be using all of the numerical values such as weight, length 1, length 2, length 3, height, and width as our independent variables. And our dependent variable will be species encoded. That's why for our correlation matrix, we will put this one. We will put all the numerical values. And for the CMAP, let's try to implement the CMAP of this one. Data is not defined, so we will just replace data as fish because that's what we done earlier. Okay, so this is our value. If it is close to pangit ng kulay, no? Yellow, green is blue. SNS. SNS pala gamit dito. Teka, anong gamit dito? Heat map. We'll try to remove this one. Try natin i-remove to. Para hindi siya red. Ayan, okay. Taguin natin to. Wala palang ganun. Ayan. So dito, meron tayong heat map. Pag mas matingkad, pag darker, darker the color, the greater the impact or the correlation. So if we're trying to compile it with the species encoded, yung height yung pinakamataas yung correlation. -70. Ibig sabihin, siguro, yung mga fish na to, paiba yung species, pataas ng pataas yung height ng species. Tapos yung iba is mababa na siya. Like 0.31, 0.27, 0.28, 0.34. So yun lang yung mga lumabas sa correlation natin na mababa pagdating sa species encoded. So I think it's better to implement species encoded at saka height. Okay? So this is our splitting of data. Data preparation. So for our data preparation, wait for a minute. For our data preparation, our X will be fish, species will be fish, height, and our Y will become fish, species encoded. Okay. So we choose height and species encoded because our correlation tells us that height is more higher than the rest. So we eliminate them. And then we split. We split again and do the linear regression, X train, Y train, the fitting, X test and Y pred. So let's run this and let's run this one. So for our accuracy, it's around we can say that our R squared, paano may computation sa taas? Our R squared so we can copy this, then implement it at the bottom for the accuracy. So y test, y pred. So let's just copy the code about. Where's this? So it's 49. All right. So this one is only using the height and species. And for this one, it's using all of the X or our features. So including length 1, length 2, length 3, height and width. So there are two styles that you can use. The one that eliminates the others and the one that includes all. However, in this one, we use weight. Instead of species prediction, we use weight prediction here. Okay. So this is for the, it's not the width, it's the species. So let me just copy this one and then place that here on just below the species encoded. So this is the species encoded, and our mean square error is around 2. So our mean squared error is 2.15. For our species encoded, it can accurately predict your species based on the data with 2.15 mean square error. So if we are going to use that in production, let's say, let me have another copy of that program. Nasaan na ba yan? So, ibig sabihin, dito sa baba nito, please enter the height of the fish to predict the species of the fish. So, height fish, height input, and then height input will replace this one. Okay, let's run the program. So let's say the predictive, hindi siya weight, let me just, it's height. Given the actual height of the fish, we can predict its species, we can predict the species, right? So let me pause this one. Let me run this one first with the modification. So this is the species on the left side or our y-axis, and then the actual height. Height ba yan? Height. Height, tama. Actual height yung ipe-predict natin. Alright? So given that we know the height of the fish, let's say if the height of the fish is from the range of 0 to 6, let's say 3.3 is the height of the fish. Enter. So it will predict that the fish is on the species around 3. No? So pangilan yung 3? 3.3, pangilan yun? Ay, sorry. Ito pala yung code. Mali ako doon. Ayan. Species unique. Yung 3.3 is 1, 2, 3. Whitefish siya. Ay 0, 1, 2, 3. Parky pala siya. Isa siyang parky. Kasi sabi dito sa prediction natin, it's 3.7. So, pwede rin siyang maging perch. Kasi pag ni-round off natin to, 4 na siya. So, it's around parky or perch. Yung fish na prediction natin. Base sa height. No? Base sa height. Okay? Did you get that? I'm going to share to you this file so that you can practice for it. So in our chat, I provided you the new copy of the file, the updated version. And then, ito naman yung nasa baba niya. This is using all of the features versus the weight. So in this one, we're going to predict so this is more of like predicting the weight of the fish. And predicting the weight of the fish. This one is more of like Okay, so do you have any question? So this one, the real estate, it's your turn. This is going to be your assignment, the real estate data set. Okay, so on your task, you will be using the real estate data set. Determine the R squared of the regression. Not the Y test. Um, then also provide the mean square error. So what are the best features to use as an independent variable to estimate the house price dependent variable? And then show the graph. So that's your task. Okay, so do you have any questions for our lesson today? The real estate data set is your turn, no? So you will submit that. So you will submit it. Submission. Uh, okay. Do we have any questions in our topic for today? Do we have any questions? So basically, the assignment uses also the same flow. So for you not to get lost with your assignment, try to follow the example of the fish. Try to follow this example, the fish market dataset for predicting the fish species. All right. So if you don't have any more questions, we can conclude our session for today. And we can see each other for next week, next meeting for session 6. Session 6, uh, we will be talking about logistic regression for our next session, which is session 6. Okay?